Good day class and welcome to Mathematics 8. In this video, we're going to talk about solving system of linear equation in two variables. And for today's goal, we are asked to solve system of linear equation in two variables using the following method: Graphical Method, Substitution Method, and Elimination Method. Let's have first the Graphical Method. System of linear equation in two variables can be solved using graphical method. To find the solutions graphically, graph both equations in the Cartesian plane, then find the point of intersection of the graph if it exists. Our knowledge in changing a linear equation to its slope-intercept form, or in the form of y equals mx plus b, is very helpful in understanding this lesson further. Let's have a review with the kinds of system and the types of graph we have. If we have consistent and independent system, we have an intersecting line. If we have consistent and dependent system, we have coinciding line. And lastly, if we have inconsistent system, we have parallel lines. This time, we are asked to write the given system of linear equations into its slope-intercept form in the form of y equals mx plus b, then find the value of the slope and the y-intercept. We have 2x plus y equals 1 and 2x minus y equals 3. Let's write the first equation into its slope-intercept form. The slope-intercept form is y equals to negative 2x plus 1. Then, the slope-intercept form of the second equation is y equals 2x minus 3. Going back to our first equation, the value of the slope is negative 2 and the value of y-intercept is positive 1. While on the second one, it is 2 and negative 3 respectively. We had the system of linear equation in two variables of 2x minus y equals 1 and 2x minus y equals to negative 5. So if we are going to write the two equation into its slope-intercept form, it will be y equals to 2x minus 1 and y equals to 2x plus 5. So the value of slope and the y-intercept will be 2 and negative 1 and 2 and positive 5. How about on the last one? If we have 2x minus y equals 1 and 4x minus 2y equals 2, what will be the equation in its slope-intercept form? Correct. The first equation will be y equals to 2x minus 1. How about the second equation? Correct. It is y equals to 2x minus 1. Obviously, the value of their slope and their y-intercept will be positive 2 and negative 1 respectively. This time, we are asked to graph the given system of linear equation in the Cartesian plane. So we have 2x plus y equals 1 and 2x minus y equals to positive 3. First thing to do is to rewrite it into slope-intercept form. Find the value of their slope. Find the value of their y-intercept. Then using their y-intercept, determine the coordinates of the said equation. So if we have positive 1, it will become 0, 1. And if we have negative 3, it will become 0, negative 3. So plot the point 0, 1, then apply the concept of price overrun, negative 2, then one step on the negative side. Then on the second one, 0, negative 3, rise 2 step, then 1 step on the positive side. So the next point will be 1 and negative 1, and that will be the line for 2x minus y equals to 3. Type of solution is consistent independent. The graph is intersecting. Solution 1, slope and y-intercept is obviously not equal. This time, we're going to use the elimination method. System of linear equation in two variables can be solved using elimination method. The goal in using this process is to obtain two equations whose sum or difference will be an equation containing only one variable. The steps using elimination method. First is to write both equations in the standard form of ax plus by equals c. Second, add or subtract the equation to eliminate a variable. The sum or difference should include only one variable. Third, if there is no variable eliminated after doing step 2, then make the numerical coefficient of one variable similar by multiplying one or both equations by an appropriate number to eliminate a variable. Next, continue solving to get the value of one variable. Then, substitute the result in step 4 into either of the given equations and solve for another variable. And lastly, check the solution in both equations, then write the solution set. Is that clear, class?
Yes!
Let's continue.
Let's have this example. X minus y equals 4 will be equation number 1, and 2x plus y equals 11 will be our equation number 2. So we already have unlike sign for the variable y, so we can easily eliminate variable y. So let's rewrite equation number 1, x minus y equals 4, and rewrite equation number 2, which is 2x plus y equals 11. Then add the two given equation. So x plus 2x is 3x, obviously we cancel y, equals to 15. To get the value of x, we divide both sides of our equation by 3, therefore x is equals to positive 5. Then, next thing to do is to find the equation of y using equation number 2. So if we have 2x plus y equals 11, let's substitute the computed value for x, which is 5. 2 multiplied to 5 plus y equals 11. Then 2 times 5 is 10 plus y equals to 11. Then let's move 10 to the other side of the equation, or additive inverse. So y equals to 11 rather. From positive 10, it will become negative 10, therefore y is equals to 1. So we already compute for the value of x and for the value of y, which is 5 and 1 respectively. For us to check if the computed values are correct, we need to substitute the value of x and y in our two given equation. Let's have first the first equation, x minus y equals 4. So let's substitute 5 in replace of x, and let's substitute 1 in replace of y. So 5 minus 1 is obviously 4 equals to 4. So correct. Let's have the second one. If we have 2x plus y equals 11, then let's substitute 5 in replace of x and 1 in replace of y. So 2 times 5 is 10, plus 1 equals to 11, and 10 plus 1 is obviously 11 equals to 11. Correct.
Lastly, we're going to use the substitution method. In this method, we solve for one of the variables in one of the equations, and then substitute that variable in the other equation. It is anchored on the substitution principle, which states that if two expressions are equal, then either may replace the other without changing the equality. Let's have this example. Mr. Marquez plays a guessing game in his class. Whoever guesses the number of chocolate bars and candies in 2 jars correctly gets to keep them. he gives the following clues. The number of chocolate bars added to twice the number of candies is 33. Then the number of chocolate bars is 6, less than the number of candies. So we let x as a number of chocolate bars and y as a number of candies. So if we're going to translate the two clues into an equation, we're going to have x, which is the chocolate bar, plus 2y added to twice the number of candy, equal sign is 33. Then the second equation is x, the number of chocolate bar, equals is y minus 6, which is 6 less than the number of candies. Is that clear, class? Yes! Okay, let's continue. The substitution method. First step is to solve one of the equation for either x or y. Second, substitute the expression obtained in step 1 into the other equation. Third, solve for the resulting equation in one variable. Fourth, find the value of the other variable by substituting the solution found in step 3 into any equation containing both variables. And lastly, always check the solution in the original equation. Is that clear, class? Let's have some example.
Let's have some example. So if we have x plus 2y equals to 33, it will be our equation 1, and x equals y minus 6 will be our equation 2. Let's use substitution method. So using equation number 1, which is x plus 2y equals to 33, we're going to substitute equation number 2 in the replacement of x, which will become y minus 6. So we have y minus 6 plus 2y equals to 33. Then let's move negative 6 or additive inverse to the other side of the equation. So we're going to have y plus 2y equals 33 plus 6. Then combine the similar terms. Y plus 2y is 3y, and 33 plus 6 is 39. So divide both sides of our equation by the numerical coefficient of y, which is 3. Therefore, y is equals to 13. This time, we're going to find the value of x using equation number 2, which is x equals y minus 6. We're just going to substitute the computed value of y in our equation number 2, which is x equals to 13 minus 6. So x is equals to 13 minus 6 is obviously positive 7. So the computed value for x is 7 and the computed value for y is 13. So let's have the checking. So we need to substitute the computed value for x and y in our two equations. So let's substitute x in replace of 7 and substitute 13 in replacement of y. So we have 7 plus 2 multiplied to 13 equals to 33, and 7 plus 2 times 13 is 26 equals to 33. And if we're going to add 26 and 7, we have 33 equals to 33. Correct. Now let's compute it in our second equation. So x equals y minus 2 6. So 7 equals to 13 minus to 6. 7 equals 2. If we're going to subtract 13 and 6, the answer is 7. Therefore, there are 7 chocolate bars and 13 candies. Is it clear, class?
Yes! Wow.